Hello! Okay, I think the mic is working. Welcome back, everybody. This is day 9 of My Tutor AI Squads, and today we're going to be covering more different machine learning algorithms. This time we're going to be looking at decision trees and hopefully comparing it with some of the other algorithms that we've looked at over the past 2 days. It is 5 o'clock now, and as always, we'll be starting at around 5 past. So don't worry if you're just joining us, you've got plenty of time. Sit back and relax, and I will get up my setup because as I was about to start the stream, my computer decided it wasn't gonna do any of the Streamlabs stuff, which is fantastic. So now I've got to get everything back up, but that's okay. But yeah, should be a really exciting stream today, so hope to see you all there. And we've got a lot to have a look at, so yeah, I can't wait to see you all, guys. And now I gotta find all my stuff here. But yeah, for those of you who are just joining, if you wouldn't mind saying a quick hi in the chat, just to let me know you're there, how your week's been, anything you've been up to. Yeah, be great to hear, be great to see. And as Inga has pointed out in the chat, and I will say it again, there is a link that you can use to share these with any of your family or friends. So if you ever feel inclined to share someone these streams and show everyone the kind of things that you get to learn, then, you know, that link is always there. Sorry if I'm a little less chatty than I normally am. I'm just trying to get everything up as everything decided to not work the second I started this stream. Which I feel really sums up my day. It's been a very, very strange day. I don't know if it's been strange in other parts of the country, but today the weather has been the most weird weather I've ever seen in my life. It started off today absolutely snowing it down. Very, very strange weather for March. And then this afternoon, there is not a single piece of snow on the ground, and it is lovely shiny sun. It doesn't make any sense. I wonder what the weather is like where all of you are. Maybe you'd be having completely strange, abnormal weather, just like me. Or maybe it's been totally normal for March, but we'll have to see. Anyway, like I said, this stream will start the teaching adventure at 5 past, so you've got 2 more minutes. Official Spoon says it's been really sunny today for me. That must be nice. That must be really nice. We've had, I live in Glasgow, and we have sun. We do have sun, but it's very, very, spurious. It doesn't happen very often, and when it does, it's still very cold. It's not very, like, warm. It doesn't really do what the sun is meant to do, which is to keep you nice and warm. It just kind of exists, and you're there really cold. I hope wherever you are, Official Spoon, that it's both sunny and warm. That'd be nice. But I wonder what the weather's been like for everybody else. Maybe everyone's had thunderstorms and snow. Who knows? Just to let you guys know, we've got about 1 more minute left. If you guys want to grab a drink or a notepad or whatever it is that you like. Hello, Michael. Nice to see you again. Hope you're having a great day. Oh, there we go. It is 5 past, so we will get this show on the road. I do apologise for being a little more haphazard than I'd normally be. I would like to be more prepared, and I had every single thing up on my little screen, and now they all disappeared. So, sorry if I'm a little bit more disorganized than I normally am. But that is 5 past. So, everyone, first of all, can you see the presentation up on the screen? Please type yes into the chat if you can. That helps me out a lot. And if you can't see it, just type no, and I'll see if I can figure it out. Official Spoon says yeah. Okay, that means I've got the go-to from Official Spoon to start. So let's start then. Welcome back, everybody, to another My Tutor AI Squads. This is the penultimate episode. This is day 9. We're getting towards the end of this. There's a little bit more content to cover in terms of machine learning algorithms. Particularly today, we are going to be looking at decision trees. And if we have any extra time, we may even get onto comparing algorithms and the process of evaluating how good your algorithm is and evaluating it against other different algorithms, which is an important process. There's no point just choosing an algorithm out of the blue if, 1, you don't know how it works, and 2, you don't know how well it works. You want to be able to say, this is how accurate my system is when you're designing one. So, without further ado, let's have a look at decision trees. Now, we talked about decision trees a little bit, I believe week 7, we covered it, but we haven't actually covered it in full. So, what decision trees are, is they are a big group of questions. So I've got one here, which is used to determine what kind of animal you're looking at. So you start at the top of the tree, the first question being has feathers, true or false, and then you go down each question until you get to your answer. So each question helps you narrow down your options until you arrive at a decision. So a decision tree can kind of be like a game, which helps you make choices based on a series of questions. So in a decision tree, this first question at the top, that's called the root of the tree. And each answer to that question leads you to a different branch of the tree. You can see where the tree terminology is coming in here. And each branch of the tree represents a different path you could take. And then each subsequent question is like a fork in the road, and each answer leads you to a different branch. And then by following the branches of the tree, you reach a final leaf, which tells you what to do or what answer you want to get at. So a decision tree is basically just a way of breaking down a big decision, what animal am I looking at, into smaller, more manageable steps. It can be a fun way to make decisions, and it can help you explore all your different options before choosing what to do. And we can actually use this in machine learning programs. Does that all make sense to everyone? Does anyone have any kind of question before we move on? I'm seeing yes and yee from Michael, which makes me think that you guys are fully happy with this, no questions. If you do have any questions, feel free to ask. I'm not scary. I'm more than happy to answer questions. But yeah, let's jump into this then. So, we are going to be using a database from the website Kaggle that we used last time. For those of you who don't know, Kaggle is just a database website, which you can use a bunch of different CSV files and you can get them for free. You will need to sign up though with a Google account or an email or a Facebook account if you've got one of those. You will need to sign up to those, but the database we're using is this one here. I've linked it in the chat and I'll quickly just show it on the screen now. Here it is. So it is a database containing, okay, I realize this is not the most fun subject, but it is US car accidents between 2016 and 2021. I've reduced this database because it contained information from all 50 states, and I've just pushed it down so it only contains data from Montgomery, Pennsylvania. But it has a bunch of different data in it, and I implore you to have a look. It has the ID, the severity, the start time, the end time, the city it was in, the state, what time it was, what was there any sun out, what was the weather like, all that kind of funky stuff. So you will need to download that database and have that on your computer. I recommend it on your desktop. You'll have to unzip it in the same way that we did before. If anyone needs me to go through that, I will. And we will also be using Google Colab today to do all of the programming-y stuff. So I'm going to link that one as well. Here it is. And we'll be using this website. So I'm going to put that up, the website up on the board so everyone can have a look. And then I'll give you guys a few seconds just to get yourself sorted. I give you guys a lot of information right off the bat there. So yeah, this is Google Colab. For those who've been with us for the past few weeks, should be very, very familiar. For those who haven't, it is a Jupyter notebook. It is a Python notebook that you can write all your little Python text on it, and it runs on the browser, which is really nice. Oh, and you can just get it by having a Google account. So we're going to use this today, and we're going to create a notebook. And we'll call it something fun, like US car accidents or something. But yeah, I'll give you guys a few minutes. Message me in the chat. I'm going to start in like 3 minutes anyway. But if anyone finishes earlier, just quickly type me in the chat so I can know when to get started. US car accidents. So hopefully we're gonna look at decision trees for definite today, and then we might look at KNN and naive Bayes algorithms. For those of you who haven't been with us, KNN and native Bayes algorithms are two different algorithms that we've used in the past. And if you're interested in finding a bit more about those, I recommend you check out episode 7 and episode 8. But yeah. When you guys are ready for me to rock and roll, let me know. Oh. I'm going to pause it. There we go. I'm also slightly still sick from last time. I think I told you that I had the flu last time, and I was very, very sick. But I'm a lot better now. Just still got the cough from last time. So we're still just healing. Aww, thank you. That's really sweet. Thank you, Michael. Okay, official spoon is good to go. I will get started then, and if people need me to stop and slow down at any point, I will. So, same with Michael. Fabulous. Right, so we will do what we do every single time, and we will import the libraries first. I like to do that because it puts them all at the top, gets them all out of the way. So we are going to be using NumPy today. This is just as NP, that's just a mathematical library. in Python. We're also going to be using pandas for all of the data manipulation stuff. We've used pandas for the past few sessions, so none of this should be too weird to you guys. And then we're going to be using sklearn for our decision tree algorithm. sklearn has quite a lot of different algorithms if you guys are interested in looking at them. So this is, you also don't need to write the comments. This is just for your benefit when looking at it. But from sklearn.tree import decision. I've got to make sure I spell this correctly. That's what it's tree classify. Yep. There's also going to be two other ones that we're going to get today from sklearn. This is sklearn train test split and sklearn accuracy. So one is to split the data and one is to compute how accurate our algorithm is. So we're going to add these in now. sklearn dot model selection import train test split, and then from hang on, I've just seen a comment in the chat. I'm going to get to that in just a sec. Import accuracy score. I see from Michael that he's asked, how do you make a new thing like what you did, Miss? I'm assuming, how did I add in like this text bar here? So at the top of the notebook, there are two different buttons, one that says add code cell and one add text cell, and they each add, so if I press code, it adds a code cell below. And if I add text cell below, and it adds it to whatever thing I'm below. So if I add this again, if I add another text, it'll add another text thing. I'll get rid of that. And then you press delete if you want to get rid of anything. So that's how you do it. You get text from this one, code from this one. That's why people quite like notebooks, is because you can have text in between the code to explain what you're doing, and it looks nicer. It looks a lot nicer. So these are our 5 libraries. Comet says A up. Nice to see you again, Comet. Official Spoon has put the code in the chat from right now. So cool. Thank you, Official Spoon. If you have any problems with the code or anything, just let me know. But hopefully that should all build up and that should be fine. Just connecting to the server there. Oh, I spelled something wrong, haven't I? Hang on. I see there is a question in the chat and I will get to that. It's metrics, that's why. Did you do new text? Okay, for this one here where it says looking at decision trees, that's text. That's all text. And then if I just click off it, no, it will just be text. But this one here is code. So this lovely part here is, you can tell because this kind of text font they use for code. Okay, so that's all the libraries done. The next thing we're going to do is we're going to add in our dataset. And we're going to use that using the data importer from before. We're going to do that in a new code block. All right, farm google .collab import files. And then I can't write. There we go. New line. And then I'm going to create a variable called uploaded, and it's going to be files.upload. And when I run this, it's going to then create this little browse button, and I can go find where I saved my dataset. And it should be called data reduced. There we go. And this should take a little while to load. I tried to use the full data set in the morning, and it took about 2 hours, I think, to download because it had data sets for 50 states across 5 years. So this is why I added the slightly smaller set from only one city in one state over 5 years. And as you can see, that takes a lot less time to download. So I'll keep this, I'll have all the libraries up there as well, so in case anyone's still copying away while we're waiting for the data set to upload itself. Those of you who are waiting, feel free to have a look at the actual data set itself. It's pretty cool looking. There's a lot of information in there already, even though it's taking not that long to download. There's quite a lot. So that's the data set all loaded up. Now we need to prepare it. So let's have a look at what we're looking at first. I'm going to click another code block, and then I'm going to create a variable to read in the data. So we'll call it accidents underscore df equals pd for panda read underscore csv, and then the name of the csv file. So data underscore reduced dot csv. And if I print the accidents underscore df dot head, that should print up the top of the data set if I spell everything correctly. Yeah, there we go. So there's quite a lot in the data set already, as you can see. You've got the start time, the end time, the latitude, the longitude, the distance, the exact description of where this took place. But the thing that's quite interesting, the thing that we're going to focus on, is the severity. That's our label. So in this data set, there are four different types of severity, one being the least amount severe, 4 being the most severe, and that's what we're going to look at. So, but of course, as always, we need to actually prepare our data. So I'm going to make another code block to make sure that our data is in tip-top shape. And the first thing that we want to do is we are going to have to select the relevant features. So if I type in accidents underscore df.info, this will tell us all of the columns. So you can see there's quite a lot of them. There's 30 in total. Actually, no, wait, I'm wrong. There's 46. And not all of them are going to be useful to us. And the ones that we're going to look at today are only going to be the ones that are numbers or binary. So things like start time, stop time, things like that. Anything that's words, like city and stuff, today we're going to get rid of it. There are ways to convert it in a way that we can use, but we're just going to get rid of it for now. We're also going to get rid of anything that has nan values in the rows. Nan means like there was nothing there. Some of them might have that, like precipitation is one of them, because there may not have been any precipitation. But if we try and put that into a machine learning algorithm, it's not going to work. So I've made a list of all of the ones that we can use, and we're just going to use those for today. So I'm going to copy this feature list because I've got it in a place to use. So under info, I'm going to write feature list. LST equals. This is going to be a Python list, and I'm going to copy this Python list both into this and the chat as well, so you don't have to type any of it out, because who can be bothered to type that out? There we go. So this is the feature list. It's too big to type out. Oh, okay. That's fine. It doesn't need to be. So that's the feature list. And I'll copy it as well, so you don't have to type any of that out. And these are all of the features in the column that we're actually going to have a look at. So we've got about 5 more minutes, so I'm going to try and make this as quick as I can do it. So once we've got our list of all the features that we're actually going to look at, anything that doesn't have any text or, anything that doesn't have any text in it, and we've removed all of that, we now need to separate our data into parts within. Wait, we haven't actually got rid of anything that wasn't on the feature list, so I'll show you how to do that. So accidents dot underscore df cell equals accidents dot underscore df, and then we only want things that were in the feature list. So feature underscore list dot copy, and that will get everything, all the data from it, but only of the stuff we want. I'll run that, and hopefully that should work. Brilliant. Now that we've done that, we're going to separate out our labels from our data. A label is the stuff that we actually want to test, and the data is the stuff we test on. So in this case, our labels are going to be the severity. We want to see how severe these accidents are going to be between the 1 and 4, like we described before. So we're going to have a variable called labels, and it is going to be our variable name, just severity. So we're going to write severity in there. Oh look, it's even helping me out. That's nice. And we're going to have our data, which is going to be everything else, but we're going to drop the severity. Accidents. Oh, this is nice. Helping me out. Dot drop. And then we're going to write severity. Making sure I spelled it correctly. There we go. Access equals 1. And we'll give that a quick run to make sure that's all working correctly. And it is. Fabulous. Okay. We'll add a new code block. The next step is we need to split our data between a testing set and a training set. We've done this already before 1,000 times, but we're going to use a actual splitter to be able to do it for us. So we're going to split it into 4 variables: data underscore train, data underscore test, labels underscore train. This should all really be self-explanatory, but if you've got any questions, let me know. Labels underscore test, and that is going to equal train dot underscore test underscore split, just like the library that we imported at the start. And inside we want to split our data and our labels for our 2 variables. The test size we're going to give to be 0.2, and then the random state, because we want it to be a random data set, is going to be 21. And I also want to stratify the labels. So I'm going to make sure that all runs. Yay, it runs. I know I'm going a bit quick, but if you guys need me to slow down at all, let me know. Okay. Aw, thanks guys. That's really sweet. But yeah, if you can smash that like button, it'll make me very, very happy. It'll actually make my day. Okay. Nearly there. So now that we split our data into our testing set and our training set, Well, we've got to actually train this model now. So we're going to create a decision tree model. Decision tree model. And we're going to make it unsurprisingly, a decision tree classifier. If I could spell decision tree classifier. Honestly, the biggest test in coding for me is spelling. It really shouldn't be, given my age, but it is. So that's how you set up a model. You just say that you want to do a decision tree classifier. Now we've got to train the model. We'll do it saying decision tree model dot fit, and we're going to fit it with our data, the training data, and our labels, the severity part. We're doing the training stuff. Now we need to get a prediction of the severity using our test data. So this is data that the model hasn't seen before. So it's going to do some predictions on what it thinks the severity is going to be using that data test. And then we'll see how accurate it actually is. So we're going to put pred_dt. I might have to run like 2 minutes over. I'm so sorry, guys. Decision tree model dot predict. Hopefully you guys are a lot better at spelling than I am. Data_test. Okay, let's all run that to make sure that works. Okay, so far so good. So far no break. That's good to see. And then, once you've done that, we can actually have a look at the data test versus the actual data. So if I print out a random 20 labels in our data set, so let's have a look at what we get. Did I write it wrong? Oh yeah, I did. Well, labels test. So it's a lot of 2s in the severity. Let's actually do 20 to 40. So this will do the numbers between 20 and 40. There we go, we got a 4 in there. So most of them are 2, but one of them are 4. Now let's have a look at what it predicted it would be. So it predicted that the numbers between 20 and 40 would be... Yeah, that's basically bang on. So there's a lot of 2s and then 1 4 at the end, and it was 106 to the right, and yeah, it's pretty damn accurate. And if you wanted the actual accuracy measurement, as this, looking at it is cute, but it's not actually accurate. If you want the actual accuracy, you can use an accuracy score from the library we got earlier. So you can write accuracy underscore dt equals accuracy underscore score. And that will give you, if you put labels and your actual prediction, it can give you an actual score of what your accuracy is. So if I print out accuracy, it gives it between 0 and 1, so if you want it as an actual percentage, you've got to times it by 100. But if I print that out, what did it do wrong? Labels did test. Oh, that's because I wrote that wrong. Okay, so it's about 95% accuracy. That's pretty good. That's pretty good for not all the data. And yeah, that is how you write a decision tree classifier using sklearn. Hopefully you guys enjoyed that today. Sorry again, it was a little bit rushed, But hopefully you have a better understanding of how decision trees work, and not only how they work, but also how you can use them and how you can test their accuracy. I hope you guys enjoyed this episode, and I hope I'll see you for the last one. But bye for now.